Hey everybody, this is Larry. This is me doing a bonus premium question, getting my money's worth hopefully. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, which is not the SQL one. Let's do one that isn't SQL. I keep on saying it, but it's still true, which is that I gotta, one day, yeah, I got one day do an SQL question so they don't come up. Anyway, okay, today's problem is 711, number of distinct islands 2. So you're given an m by n binary matrix, an island of group of ones, connected 4 directionally. An island is the same, they have the same shape. Return the number of distinct islands. This is a very tricky one. I haven't done this one yet, obviously only because obviously only because, well, if I've done it, it wouldn't have showed up. But I have solved this problem on this site, binary search, which is no longer up, so RIP. But in any case, yeah. I'm just trying to think what was the best way about it. I mean, I think the easiest way to think about it is just about fingerprinting this and then doing a regular connected component thing, and then fingerprinting it afterwards. That's really the idea. There's really nothing too tricky about it in terms of concept, but it can be but it can be hard to implement quite correctly. The thing to note is that it's 50 by 50, so hopefully it should be okay. So let's yeah, let's get started then. Okay, so yeah, so scene is equal to, but yeah, I don't have much to add about it. It's just, regular. The core idea I think is pretty straightforward, but once again, the implementation could really be messy. So yeah. Grid of x, y is equal to 1, and oops, how did that happen? Yeah, I mean, I'm just trying to think whether I should prematurely optimize a little bit. Otherwise, the space compare, like we do a lot of recursive things. The space complexity may be a little bit tricky, so let's kind of let's do a premature optimization. I mean, it's not that big of a deal so far, but yeah. And as you can see from the structure, though, at least this part of it is just very standard connected component depth first search. Though maybe I could have done it with breadth first search. I still can. So yeah, maybe I'll do it with breadth first search just so that I can. So I think the space is better controlled this way, so I don't need this anymore. I can do something like this, and then we'll add some stuff to it, but you'll see. Yeah. Okay. What am I doing? Okay, yeah. And basically this is very standard breadth first search to get connected components. The naming is terrible, I'm not gonna lie. well, the ping really loud outside, as you can see, or hear maybe not, I don't know. Let me know if you hear it. Just keep track of all the islands. And then now we sort it, and then basically part of the idea about fingerprinting is going to be a little bit tricky, only because there's rotation and reflection, which is kind of just like annoying to do. I mean, it's not hard even, it's just annoying to do, right? So yeah, yeah, I mean, it is what it is. So now that we sort, and then we can return current. I think let me try to think. There really isn't that, like, with, I'm trying to think whether there's a way to fingerprint it without explicit rotation and reflection, but I guess it is what it is. So so we have to do it, I think. Yeah. If no match, and this is pretty straightforward in theory. This magic function is where the difficulty is, of course. Yeah. Okay, and then basically what we want is that we want can I do that? I don't know. Let's see. Basically, another scene, right? First of all, we want to normalize it by finding a corner. So min x is equal to infinity, right? It doesn't really matter. Equal to min y is equal to min infinity. Max x is equal to max y is equal to negative infinity. And then now for x, y, and island, min x is equal to min x. And the same thing for the y's, right? Yeah. Okay. So now we normalized. Oh wait, no, we haven't yet. And then for I in range. Oh, well, I guess that part doesn't matter. What I want is this part. Whoops. Yeah, okay. Right, okay. So then now we can do a fingerprint on it. This is so annoying, but okay. So yeah, that's actually, yeah, okay. And then now max x, we can max y, we can subtract this as well. I wonder if this works. Let's see. I'm just gonna run it just to see if it complains about. Yeah, that's what I was worried about. Because this is, okay, fine. Fine, you get your tuple. This is now work. Okay, so at least that kind of is good. What does it return? 1? No, yeah, because they should match. Okay, so yeah, yeah, otherwise, scene island dot add double island, right? Otherwise, island is equal to just say rotate island, right? By the coordinates, and then we can do it 3 times or something, right? This is kind of yucky, but I guess I could do it with a for loop. Okay, fine. Right. And then last time we'll get it the same, right? And then now we do it again, but with refraction, right? And that's pretty much the idea. Of course, we have to actually implement these things, which is a little bit harder, but yeah. I think this is technically the new R and C. And then basically, yeah. I mean, it doesn't really matter which way you rotate, but let's see, right? So you go from 0, 0, you go to. These things are always hard for me. Hang on, I have to visualize it. So XY goes to R. Is it Y R minus X or something, or am I confusing things? Because basically, you're in the first column, you're gonna be on the first row. If you're on the second column, you're gonna be on the second row. Yep. And then now the row, if you're on the first row, you're gonna be the first. If you're in the first row, you're gonna be the last column, and so forth, right? I think this is -1, but yeah, okay. Yeah. Let's take out the reflect for now, and then oh, whoops! I thought I had a scene island thing. Scene islands that miss an S. Well, we got this one right, I guess, which is nice. Okay. Oh yeah, because we didn't do the reflect. No. No, but it still should work. Let's see. Because it rotated if it rotates twice, it should be good. Unless I'm missing something. Which, is very possible. Let's take a look. I'm happy that the other one. Oh, I guess the other one doesn't need a rotation. That's why. So you have 0. Oh. Why do I have 4? I think I messed up something. That's why, because I duped one of the things. Current. Did I mess up something? Why would this do it twice? Current XY. That's weird. Did I make a mistake here? Yeah, why did we return the first 2 elements twice? The first element twice, rather, not the first 2. But XY. Oh, because we don't set scene of xy is equal to true. Okay. It's still wrong, but I appreciate for trying. Okay, now let's see. Okay. Maybe I have an off by 1. Maybe I need a C somewhere. How come there's no way that we don't need C in this? So that's just a little bit weird. Yeah. Because we have this island, and then we flip it and we go here. That doesn't make sense. Okay. So 0, 0 goes to I mean, yeah, this doesn't make sense that you have a -1. Well, maybe it does. Well, okay, I see. It does, I think. Yeah, it does because this isn't a square, that's why. So that means that I have to... This has to change a little bit. Okay, fine, you just don't use this then. Oops, that I need at some point. This I don't need. I actually never need the max. So let's get rid of it. Yeah, okay. I mean, I don't need the max there, but I do need the max here, I think. So, the mins will be 0 just because that's by definition. This is so annoying. Yeah, I think that's true though. What? I don't know why I do it this way, but okay, fine. And now this is... I think I used the wrong one. No, is it? The column is equal to... So, column is going to be equal to the row. Yeah, I think this is now right, maybe. Maybe I did that wrong. Alright, and then now... Alright, let's just print this real quick. This one has gone on for so long. Okay, so... Let me at least draw it out so that I can, even though if it's not right. So 0, 0, 0, so that's just this one. And then now 0, 0, 1, 0, and then 0, 1. So I guess it's rotated. It's just, it goes on to infinity. Okay, fine. So then now, min x is equal to y is equal to infinity. And then now, x is equal to min of min x, and then min y is equal to min of min y, mxy minus x minus 1. And then now we do it again. I guess they're both the same, but I think I had a thing here, right? So it's just this. I could just copy and paste, except for now it's called new island. I should have did a renormalization function. Maybe that would have helped. Okay. Still wrong, but let's see. Oh, whoops. Let's see. Island, new island. Oh, but then we have to sort this again. That's why. So new island dot sort. Let's do that. Okay. A lot of ways to make mistakes, but this is still not right because we didn't do the refraction. We didn't even implement it. So let's implement it. Yeah. So we did the rotate, and then we what do we call it? Refract the refraction. Because I don't need this. Refract. Okay. Yes, we don't need. Yeah. Okay. Fine. What do we need for refraction? I guess just one direction, and then that's fine because it gets all the other ones. So what we need is this thing again. I guess we just do this. Okay, and then now, yeah, new island for x, y, and island. New island is Leetcode 2. What is it? X is just x, and then y is just max y minus 1, right? We might have to sort again. Fine. Tuple object has no. New island is a tuple? Oh no, I'm looking at the wrong one, that's why. Where's my other one? Oh. Oh man, how did it get changes it to wrong? How does it changes it to wrong? Like if it doesn't do anything, how did that happen? The reason is because we're adding the reflection, but it shouldn't matter. That's weird. Well, we reflect once and then we reflect it second times. Should be okay. Should be invariant. So many. Maybe I'm just off by 1 or something. Oh, I have to renormalize it again. Okay, fine. Really? This means something went wrong, though. Max y is 1. So then now it is max y minus y. Did I not do max y right? Let's see, max y. Yeah, I don't get it. So it's 1 minus 0. Right, so where does this negative 1 come from? Huh? 1 0. That one should be 1 1. Did I just mess up or something? Oh, because max y is not the dimension. Max y is just the thing. Maybe that's why I have issues here as well. Because that's not the dimension, and I keep on thinking that's dimension, but the dimension is actually that plus 1. Now I wonder if I needed to this whole thing anymore. Let me just kind of see if I needed it. Okay, that's why I don't. I didn't think I needed this, but then that's maybe why. Well, let's just actually keep it commented out so I can uncomment it later. Where to find the other thing that I print, and then I'm going to give it a go. I guess I should test one for refraction. So you have something like this, but then maybe just add one more, like make it a Tetris thing. And then this one doesn't make it a refraction. I think adding a 1 here does, yeah, okay. Okay, so this is wrong because it doesn't handle refraction well. Okay. Do I need this? Maybe I just need this, that's all. Yeah, okay, so maybe I did need to do this. I don't need to do this here because that's just because everything is within range, so it should be okay. Let's give it a YOLO submit. Alright, cool. Pretty tricky to get right problem. It took me 25 minutes and I knew how to do it immediately, right? So definitely an implementation heavy problem, but did get it in the first try, so that's actually pretty okay. Probably could have done it a little bit better. Probably could have you know, refactor some of this stuff so that I don't have to, you know, I wrote this in a kind of messy way, but yeah, 93 lines of code. So what's the complexity, right? Each cell is only going to be seen about like 8 times, or you know, regular. So depth of search by itself or breadth of search actually connect the components, it's going to be linear, right? And then we only okay, and then there's like an island, so maybe can I do without the sorting? I mean, you can kind of do bucket sorting, but okay, fine. So maybe it's n log n just because there's a lot of sorting. And then just, you know, putting them into sets. But otherwise, everything else is just, we do things a constant number of times because the rotation and then the refraction to combine only gives us 8 possibilities, right, for the thing. I think the sorting is the only thing that kind of keeps it a little bit expensive because you have to sort the number of cells, right, and the coordinates, which is r times c, r times c times log rc or something like this, where n is equal to rc, basically the size of the input, right? So n log n time O of n space, and that's what I have, and O of n space because we only use things for, I mean, I think there's a scene away here. There's a deck, but of course that's linear because each cell can only get added once. And then where's the other thing? The island, the fingerprinting thing. Scene islands will, you know, the sum of all these things will be at most linear, right? So this is all linear space. So yeah, n log n time O of n space, and that's what I have with this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.